Okay, hey everybody. So I'm going to really quickly kind of focus on the networking infrastructure side of things, and then also, surprise us being a complete end-to-end video surveillance solution. We do offer our line of switches as well. So we're going to dive into an actual presentation there as well. So first, I want to start out with kind of, I know back in the day, our industry was completely consolidated around just analog systems, analog infrastructure. And then all of a sudden, maybe 7, 8, 9, 10 years ago, these IP cameras started penetrating the market. And now we're at the point where, let's face it, they control the industry, right? And some of the things that I've seen kind of our industry transform through or morph through is the challenges, the growing pains that people kind of have to go through to get a handle on how the networking, the virtual world of the video surveillance is going to work now, right? So there's a couple of things that I will walk through to kind of get everybody on the same standard as where i3 is currently at the moment, right? First and foremost, when we're going through our cable runs, as you can see, we do want to recommend going the Cat 6 option, just because as these cameras are getting into the 4 megapixel, into the 8K, 8 megapixel, in some cases 12 megapixel, the amount of data that they're sending through the line is just growing exponentially, right? So to kind of provide a little bit more future proof of the system, we want to go the Cat 6 option. But I understand you guys also have inherited a lot of systems out there that have ran Cat 5 standard cable. So the links standards on the networking side, I'm not even going to ask that question as a quiz. You guys can see it right there. And that's, I think, for every technician, that is just ingrained in their brain, is 100 meters and 328 feet. But a lot of times, I actually really don't feel comfortable going above the 300-foot range, just because what I've noticed is with some quality cable, that range becomes a lot smaller than with others, right? Not every cable is built the same. So that's why when we're designing a project, we typically want to keep it within that 300-foot range just to be on the safe side. Does that make sense? Any questions there so far? Olga, anything in the comments?
Not, let me see.
I know it's after lunch. I really hope I didn't put anybody to sleep just yet, but I promise you there's going to be some neat things that we'll cover here that'll probably make your...
It says, can you minimize Olga? I'm blocking part of the screen. Can you minimize that?
Sorry about that.
There we go.
Sorry, Olga. Yeah, so this is just a basic kind of a topography layout, and I have a more detailed one that I'll go through eventually, right? We want to go the T568B standard, of course. That's a that's the way I think anything works in this world. And for the wireless side, 5 gigahertz, just again on that throughput, being able to supply more bandwidth and kind of increase the overall speeds. The next part is on the networking infrastructure. You have to remember that our software requires a certain set of ports forwarded in order for us to be able to provide the remote viewing capabilities. This can be both on our mobile devices, right, on our smart client, as we call it, on our thin clients, which is something that we'll get into deeper in our presentation, which is our CMS, and then on our thick client, right, what the customer would use on the remote side to be able to connect to the system, which is called Video Pilot Client. So this is probably a good opportunity. We will share this with you guys as well, but this is a good opportunity if you have a phone on you to snap just a quick picture, so you have that in your notes for the future, so that if you're on a site that, again, you're taking over and there's some connectivity issues, you can just quickly test to make sure that those ports are forwarded, and 9 times out of 10, that's kind of the result behind the connectivity problems that the customer may encounter, right? Any questions there? Oh man, you guys, this is easy. So we'll move to kind of the more now in-depth understanding of the infrastructure. So this is the typical riser diagram of how our system would be installed. So starting from the very right-hand side, and can you guys see my mouse? Olga, Bob, can you guys see it moving?
Yeah,
Okay.
absolutely.
Awesome. So we're looking at our head end right here with 3 NVRs that are processing all of these individual cameras, right? What you'll notice is that most video surveillance systems out there have 2 individual NIC cards on the back. And the reason behind that, it's critically important for the success of the system to keep the local, customer LAN traffic on one physical network, and then the camera traffic, because it's so it's so bandwidth hungry, right? It's so difficult to deal with. We want to keep that completely isolated, completely private on its own separate network, right? And I think the similar kind of explanation for that is, imagine now that we're all back home, right? And your kids are home, your wife is working from home, you're trying to do this training, and your kids are trying to watch a bunch of like Netflix videos, right? There's so much bandwidth that would be utilized from your household that you would start noticing things to really slow down, right? My voice would get really funny. You're going to start seeing like tearing in the screen. You're going to see dropped images or dropped frames. The reason behind that is there's just a bottleneck. There's not enough throughput in order to be able to push that data through, right? What we've noticed is when we try to mix these two networks together, some of the client switches, the network that our customers are already using, they're just not built, they're not designed to be able to handle so much data that is pushed out by those cameras. There's thousands of different PoE switches in the market, right? And some of them are just a few $100s, while the others, they have the same exact specs. They can cost within the thousands, so in some cases, $10,000 range. The reason behind it is just how much data is that switch able to support and handle. It's how powerful is it on the CPU side, and within the industry, we call that switching capacity, right? So if we're trying to run our cameras all on the same network and the switches were not meant or not designed to handle that, we're going to see major issues, not only on the video surveillance side, but you have to remember now all of that data is pushing through and basically causing major, it's causing havoc on the customer's network side also. They're starting to notice that their network speeds have just plummeted. They're noticing that their voice over IP is not performing very well. Well, there's our culprit right there, right? So any questions on why we very strongly recommend and why we think it's kind of the best practice in order to keep the camera network physically isolated from the local area network on the customer's infrastructure side? Any questions there? Okay, perfect. So that brings us to the next point of our line of switches. I mentioned us providing our own line of switches allows us to build in some features into the GUI that are specifically designed for the folks in video surveillance. They're not designed for IT guys that are sitting in data centers and trying to troubleshoot and isolate problems that are specific to their industry. They're completely custom tailored, right, to some of the problems that you and I encounter in the field when we're doing an installation. And you'll notice that kind of the topography I'll use is a core switch, which has a much higher throughput or switching capacity at 128 gigabits, right? It's able to handle way more data than other switches. And then something like edge switch, which is 56 gigabits per second, which is our S244 line, and our S243 line, which is great for 24 cameras or a switch that's out there in the core and doesn't have other switches running through that. Did I lose anybody yet? I promise it's going to get way more interesting from there. Awesome. So the next part is I will run through our our switch side to kind of show you what the GUI piece represents. So our default IP address to access all of our switches, and again, this is one of those moments we want to write it down, is 192.168.0.10. So if you're finding yourself in a Harris Teeter site, right, you're walking in, you've never been there before, this is the first job you're doing with i3 International, and they're reporting that, hey, we're having an issue with a camera that's just constantly dropping in and out, or we just lost it, right? It's showing up as disconnected, and we want to be able to troubleshoot it and isolate it. One of the first things that you would want to look at is kind of what is the details on the networking portion, because again, this thing holds all the keys to the data and the issues that we might see on our network side. So once you've typed in the default IP address, our default username and password for the existing stock, as Olga mentions, i3admin, and then in the future we're moving to set up a individual or a unique username and password for each site that we're accessing. And there we go. So we've logged in. It gives me a breakdown of all the ports that I have connected to this particular switch. Again, it tells me really not, it doesn't tell me what exact device is associated with that port just yet, but I'll show you how we can find that data. The next thing that we would look for is for our CPU load. So this is how much data is the brains of the switch processing, right? And is it seeing any issues? Like, is it getting overwhelmed with the total number of traffic that's running on our network, right? So I see that this switch here, it's really underutilized. It's not crunching that much data. So I should not have major networking issues here just yet. From there, on our system monitoring side, I want to take a closer look at a port by port breakdown. And if I go into my traffic overview, it gives me a statistic of what errors I am seeing on my switch. And instantly I can tell you that port number 5, do you see all those errors that it's receiving? Those errors on the virtual world reflect in the real world to, again, skipping frames, camera dropping off, tearing, like those issues that we keep on really focusing on. That's what we notice is one of the biggest issues in the industry, right? So instantly I know that whatever is plugged into port number 5 is the major issue. And from there I can go into my data management system, activate it just to make sure that this is not a system we want to run nonstop, just because it could pull away resources from the switching of the network portion. So we want to only enable it just for troubleshooting purposes. And from there, when I go into my topography view, the system will give me a layout of every single device that's connected on my network, right? It'll show me the MAC address, the IP address, what port it's connected. So now when the customer has reported that the issue was with a specific camera, instead of just randomly unplugging and plugging ports or randomly shutting down switches, I now know exactly what port that specific camera reports to. So again, as you're going into a lot of these Harris Teeter sites and you're kind of going in blind, this is a great way for you to instantly understand the lay of the land and to figure out how the cameras are connected and how the network layout is overall without like spending hours and hours and hours trying to gather all these details. Any questions there? Okay, perfect. So
Andre, sorry, Andre, I just want to remind the group that an access config tool, when that export feature, it also exports the MAC address and the IP address of your camera.
Yeah, absolutely. That's a very, very good point. And one of the things that we've mentioned in the past is like, if we're doing a brand new installation, it makes great sense to kind of give our future selves a gift and to gather some details on like how the cameras are laid out and things like that. So in the future, if we're sending somebody in from a service call, they're able to use those details and not have to waste as much time to, troubleshoot and investigate kind of down to the level of where this issue might be, right? So this is kind of a quick update or a quick example of how you can gather the lay of the land and figure out what type of situation you're actually dealing with. From there, if you go back to the switch side, we've built in a diagnostics tool that, let's say if it's port number 4 that's given us, or port number 5 that was giving us those issues, I can select my cable diagnostics, select port number 5, and instead of having to go up on a ladder, pull the camera down, right, plug in my tester transmitter on one side and the receiver on the other side, I don't have to do all of that. I can just quickly select the port that I'm interested in, select start, and the switch will run the cable diagnostics automatically without us having to do any of that legwork. Does that make sense? And this was one of the major advantages for me personally, because I remember kind of all the difficulties I would have to have with, again, if we're dealing with a scissor lift or anything on that end, it becomes a nightmare testing the cable. And then finally, the very last thing that I wanted to run through is it's very frequent for us to get calls from our customers saying that, and there we go, by the way, I see that with port number 5, those errors that I was receiving, there's an abnormal test result. There's clearly a issue with that specific cable. And automatically we would know that that cable needs to be recrimped, right? But the last final portion that I wanted to focus on is being able to set up auto checking tool, where essentially it is not uncommon for cameras just to drop off at random due to, again, maybe like the complexity of the network or maybe the cable, the crimping, just the overall connection, right? And a lot of times what you'll do is you'll unplug that camera from the PoE switch and plug it back in. You'll power cycle it, and then like magic, it just comes back up all normal again, right? But this requires a lot of legwork again, right? Time is money. For you to have to show up on site and make this very quick fix can be very expensive on, on the Securitas side. So the very last thing is we want to make sure that the system does all the hard work for us. And under our auto checking, we can enable the switch. Remember, we already know what the IP address is of each individual camera that's reporting to the switch from the DMS mode that I just showed you, right? We can program that IP address and the switch will automatically ping it at a 30-second interval. And if after 3 times it does not hear back from the camera, it will reboot the PoE port, right? Basically power cycling the camera, and 9 times out of 10, bringing it up back to the system without us having to do any of the difficult jobs, right? So again, this is a very quick, very kind of, the 30,000 foot overview, just how you can utilize the switches in your arsenal in order to maybe when you're on site dealing with these brand new systems to get a better understanding or better lay of the land of how the things were installed previous to you. I will now open the floor to any questions that you guys might have on your end.